Hello, everyone. Hope you are having a great day, morning, evening, whatever it may be. Today, I want to look at a problem. Hey, what was that? Oh, come on now. Hold on a second. And no, let's keep that away. Come on now. I've never seen this before. No, I'm teasing. I've done it before. I want to do it again. So, let's talk about the convergence of this series, x to the n. And let's say, actually, I know it converges. And I want to find what it converges to. What is this sum? The sum of x to the n as n goes from 0 to infinity. And where the absolute value of x is less than 1. Less than 1. So first off, it's funny that they mention absolute value of x is less than 1. Why would they mention that? Well, maybe because I have my n in the exponent, and that might kind of imply, maybe make me think that, hey, this is a geometric sequence or series. It's a geometric series. Okay, if that's the case, we got a geometric series. Well, we know something about geometric series, the infinite geometric series, and that is if the r, the common ratio of is less than 1, then the infinite sum is equal to a over 1 minus r. This is something we know. And if you need a reminder, what does a geometric series look like? It looks like something like this. Or like this, right? Where any ratio of two terms gets you r. Okay. So, back to this. Well, let's use this guy and figure out what this equals. It's very simple. It's very straightforward. Almost feels silly even messing with it. But hey, it does actually come up to a nice little topic here. Are details important? Of course, we're in math. Details important. This says n equals 0. This says n equals 1. Details are important. Now, is that going to change the answer that this is 1 and this is 0? Maybe, maybe not. We haven't discussed it, and I don't think it's clear whether or not it does. So let's play around with this first, and let's change that indice around. I think before we do anything, just to help us, give us a little intuition, let's just see what a few of these terms look like. Okay? So when n equals 0, I get 1. When n equals 1, I get x to the 1. When n equals 2, I get x to the 2. And so on and so forth. Blah, blah, blah. And of course, it's going on forever. Okay. We got it. Now, I don't want to, like I said, if I want to use this formula here that we've derived, we need to, well, have the left side be correct before I can figure out what the right side is. I don't have n equals 1. Right now I have this. This is n equals 0. But I want it to be n equals 1. So what if I said, you know what, I want that to be n equals 1. How would that change things? If n equals 1, then I would want x to the something to still equal 1. I remember here it was 0. So in other words, if I'm rewriting this, n equals 1 to infinity now, we're changing the indice of our summation. We're going to probably need to change our expression inside the summation. So it won't be n anymore. How do I get that to be 0 if I'm plugging in a 1 instead of a 0 to begin with? Well, 1 minus 1 would be 0. So now instead of x to the n, it's x to the n minus 1. Let's see would that work. Plug in a 1, I get 1. Plug in a 2. If I plug in a 2, if I wanted this to be 2 now, 2 minus 1 is x to the 1. Yes, okay, it totally works. So now what we got is these two guys are equal. And I'll even fit it in here. I'll say, hey, you know what? This guy, let's just make ourselves a little note that I just rewrote my summation and I changed the indice. And you guys can see if you add 1 to the index, then we subtract 1 from our n in our expression. And you can just think about that. Is that the trick? Does that always work? Maybe you should play around with a couple of these sequences and see if that always works. Okay? Now that we have this, though, we can go ahead and use what we know about an infinite sum of a geometric sequence. In other words, a geometric series, infinite geometric series. Well, I need an A and an R. In our case, A equals 1. There is nothing in front of our common ratio. There's no common, there's no A. There's nothing multiplying it. I could stick a 1 in front of there if I wanted to, and it would not change it at all. So A is 1. R, our common ratio is definitely x. Multiply by x, I get x squared. Multiply by x, I get x cubed. My common ratio is x. So R is x. And we have that absolute value of x is less than 1, which means my R, absolute value of R, is less than 1. So I can use this formula and I can plug it all in. What I'm going to get here is A over 1 minus R. A is 1 over 1 minus R is 1 minus X. Bam, we got it. This is a very nice result. And just to sum it up, one over 1 minus X. Okay. There we go. Very good result. Will be useful later on. So keep that in mind. Hope this video was useful. I hope you guys had so much fun watching it and thinking about this, pondering life's questions through convergence of series. And I'll talk to you later. Have a great day.